Okay, so one of the things that we're going to look at today is place value. Place value was a term and a way of doing math that we learned way back at the beginning of the year. And basically what it means is you are just multiplying or dividing numbers by what we call a base 10. So we're timesing or dividing numbers by base 10. Base 10 numbers are 10, 100, 1,000, etc. It's numbers that are just tens or versions of tens, right? So we'll get problems that look like 7.2 times 10. Now this is just a numerical expression, and now that we're expert fifth graders, we can think of this in a lot of different ways. We can do 7.2 times 10 and think of it as a standard algorithm. One option. Another option is thinking about your place value chart. So flashback to place value chart, where this was our first way that we looked at how to multiply and divide things by 10, really when we dealt with place value. So if I was doing 7.2, I would fill out the 7 because it is a 1.2. And then since I am timesing it by 10, that means I'm moving each digit one space over to the left. So my 7.2 becomes a 72. Remember that when you times something, you move your digits to the left. And we know that opposite of multiplication is division, so when we divide something, that is when we're going to move the digits to the right. And the number of columns relates directly to what you're multiplying or dividing it by. It relates to this number here. So the number of columns relates to if it's a 10, 100, or 1,000, etc. If it is a 10, it's going to move one column. If it's 100, it will move two columns. If it is 1,000, it will move 3,000. And we looked at the fact that a 10 you move once, 100 you move twice, and 1,000 you move 3 times, and that directly relates to the number of zeros you see in your problem. So 7.2 times 10, I'm going to move each of these numbers one space to the left, and I can visualize that place value chart in my head. Your other option is to actually draw it out. So it is 72. You could get a larger problem that was something like 3.215 times 1,000. Again, I'm going to picture that place value chart in my head, or I'm going to draw one out. Because I'm timesing by 1,000, I have 3 zeros. I'm going to multiply my number by 3. So this 3 goes 1, 2, 3. This 2, 1, 5, and then the decimal stays in the vertically aligned spot. So 3.215 times 1,000 is 3,215. Same pattern relates if you're going to divide. If I was doing 13.15 divided by 100, I'm going to still picture my place value chart because it's a base 10 number, and I can do these ones in my head. And if you can't picture, again, draw it out. I'm moving it by 100, so I know it's going to move 2 columns. But what I'm trying to decide is which direction. Because it is division, I'm going to move to the right because my numbers are getting smaller. We can bring our logic in here. So 1, 2. I get 0.1315, which really is 0.1315. So when you're dealing with place value, the easiest way is to think about your place value chart and how you're moving your numbers to the left or to the right, and depending on how big your number is, it'll tell you how many columns to move it. If the place value chart method is too confusing to you at this point, or you don't remember it, or you prefer to just do it all on paper, you can treat these numbers as a basic standard algorithm problem. We just have learned other strategies to do besides that, because you're going to end up with a lot of zeros here, which is fine. We would treat it just the same way, which would be a lot of steps, and you just have to count your decimals and plug it in, and so that's an option as well. But the easiest, quickest way is to think about your place value chart and how you can use that to help you move your numbers. Don't forget that you're not just moving the numbers, you have to think about that decimal. That decimal should stay vertical the whole time, so you're moving your numbers around the decimal. And that is a quick review on how to use place value charts and think about place value when you're multiplying and dividing numbers by base 10.